Good morning, students. Today, let us begin with Newton's force and laws of motion and proceed Newton's second law of motion. Dear students, can you think what happens when a force is applied for very short interval of time? For example, when a bat hit a cricket ball for 0.01 second. The force exerted by the bat on the ball is several thousands Newton. This effect of force applied by the bat is known as impulse or impulsive force. So impulse, just now I am showing you. Impulse is denoted by J, which is force applied for very short interval of time. So F into T. SI unit of J is force Newton, time second, so it is Newton second. J is vector quantity. This J is vector quantity. Now students, from second law of motion, we know that F is equal to mv minus u by t. The meaning of v, u, t, m, f you are knowing. So cross multiplied F into t is equal to m v minus u, that is change in momentum. So F into t is impulse, and impulse we are denoting is equal to change in momentum. So dear students, how will you define impulse in terms of momentum? Impulse is nothing but the change in momentum of a body. So till here we have finished Newton's second law of motion. I am showing you numericals. Number 1, a cricket ball of mass 0.16 kg moving with a speed of 20 meter per second is brought to rest by a player in 0.1 second. What is the average force applied by the player? So very simple. First of all, let us start with what is given. Mass is given 0.16 kg. Moving with speed of 20 meter per second means u is given 20 meter per second. The force will come to this ball will come to rest. That means v is equal to 0 and time is given t is equal to 0.1 second. We have to calculate force. Just now we have studied impulse. J is equal to mv minus u. J we are having F into T. Mass we are having 0.16. V we have got 0 and u is yours 20 meter per second. Just say 20 meter per second. So it is 20. That means we can write over here F into 0.1 and this should be 0 minus 0.16 into 20. Therefore, F is equal to minus 0.16 into 20 by 0.1. So we have got 32 Newton. So what force, impulsive force we have got? 32 Newton. For the time 0.1 second, the ball is hit by the bat. So see how much more force is exerted. Next question you come. A man pushes a box of mass 50 kg. Mass given 50 kg. With a force of 80 Newton, F is equal to 80 Newton. What will be the acceleration of the box? Means we have to find out acceleration. What would be the acceleration if the mass is half? Mass is 50 kg. What will happen when mass is half? Let us start calculating. We know the formula F is equal to ma. So here A is equal to F by m. What we get it? A is equal to F, we are having 80 Newton, by mass we are having 50 Newton. So just cut it. We will get 1.6 meter per second square. Acceleration we are getting 1.6 meter per second square. Now when mass is half, so we have got m by 2, that is 50 by 2, 25 kg. So what we get acceleration? Acceleration is 80 by 25, that is, we will get it meter per second square, 3.2 meter per second square. Now how will you verify this numerical is right or wrong? So come for formula A is equal to F by m. That means acceleration is inversely proportional to mass. If mass increases, acceleration decreases, and mass decreases, acceleration increases. So in the question mass is half, naturally acceleration will be double. So we have got the same answer. When mass is half, acceleration is double of 1.6, that is 3.2 meter per second square. So like this, in first numerical we have got the F is equal to, that is this much, 32 Newton, and this one we have got conclusion. So from Newton's second law of motion, it teaches us what is the method of calculating force. Newton's first law says the definition of force, and Newton's second law says method of calculating force. Okay.